Hi guys, today we are going to understand about three-phase circuit. Three-phase circuit about, just a minute, let me take this pen. So we'll understand about three-phase circuit and star, delta, delta in the three-phase circuit. We'll understand the relationship between phase current, line current, I phase, IL in case of star and also in case of delta. We'll understand the relationship between voltage, line voltage, and phase voltage in case of star and in case of delta. So that is what are the things we are going to understand today. Now, what is a three-phase circuit? As we have understood that single phase is what there is one phase and one is line. So this is phase and this is line. That is single phase. But unlike the three phase has three phases, so there will be two type of connection in the three phase. So this type of connection is called star connection. Means uh, let me explain you in more detail. So this is called R phase, this is called Y phase, this is called B phase. So the rotation is always anti-clockwise like this phase marking rotation. So what I wanted to say, let's in we have three winding. Let's say one motor or one transformer. Generally we have three winding, right? So three winding we can connect it in two way. It can be winding A1, this is A2, this is B1, this is B2, this is C1, this is C2. So one connection can be like this. We have connected let's say A2, B2, C2 shorted, and we have this A1, B1, and C1. So like this again anti-clockwise. So it means the three windings. If I short it here, if I short it, just using a bar, I am just shorting it. Then it will form this type of connection. Another connection is delta. This is called star connection. Star is STAR. And another type of connection is called delta. In this we'll connect the three winding in this way. Okay, so again the naming will be like this is R, this is Y, and this is B phase. And if I have a winding like this, let's say three winding connected like this, and we have a name like A1, A2, B1, B2, and C1, C2. So the connection will be like this: is A will get connected to B, B1 will connect it to C, and this C1 finally will get connected to A2. Alright, same connection we'll have to do here also. So this is A1 and B2. Let's say uh, this is A1, so this is A2. Now let's see A2 is connected to A2 is connected to C2. So this will be C2, this will be uh, C1. Now C1 is connected to C1. C1 is A2 is connected to, sorry, this A, see this A2 is connected to where? This is C1. So this will be C1, correct? This will be C1. So if this is C1, this will be C2, This will be C2. Now this C2 is connected to whom? B1. So this will be B1. So naturally this will be what? B2. So check, A1 is connected to B2, right? So A1 is connected to B2. So now this is how we need to form star or delta. That is one part. You may have in the industry, you may have this kind of winding, particularly in earlier we used to have open winding. This three six terminals are available in the terminal box, and you have to do this connection, either star or delta. Now what are the advantages and disadvantages? Why star and why delta? Let's also understand that when you're connected to a star, so this point is called neutral point, so there will be neutral line. Now when there is a neutral line, so there will be different type of voltages here. One voltage is called, this is neutral line, this is called Vy, this is called Vr. These Vr, this is called line voltage, this is line voltage, this is line, 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 and this is neutral. There are three lines. One is Vr, this is Vy, this is also called line voltage, and this is Vb, this is also called line voltage. And this one Vb, line voltage, right? Now, what is this line voltage? Line voltage is complete this. So this, let's say VYR, this total voltage is called line voltage. Now this is also a voltage like VYN from here up to this point, and that is VRN from this to this. Correct. So these voltage VRN, VRY, they are called phase voltage. They are called what? Phase voltage. Phase voltage. PHAC, phase voltage. And these VYR, as I said, VYR, or it can be VRB, these two RB, this is called VRB, right? These are called what? Line voltage. Line voltage. Line voltage. Now this is one concept, and uh, another concept is called line current and phase current. In case of star connection, you can see this line current. The same current is flowing to the phase. This part is phase, this part is phase, and out of that it is line. So phase part is what? We call it I phase, IPH, and this part is called I line. Now the same current is flowing through the line. Whatever is current flowing through this uh, phase circuit. So in case of star connection, so IL equal to I phase. So this is one relation between IL and I phase. But you can see that this voltage, this is line voltage VYR, is not equal to VYN or VRN. In fact, this voltage VYR, let me write it here, VYR equal to VYN minus VRN. So that is the equation. So this is called vector sum of two different voltages. That's how we get the phase voltage. So we'll come to this later. What is the relationship between phase voltage and line voltage in case of star? But let us understand that it is different. It is not the same. Now coming back to this delta circuit. In this circuit, look at here. The phase voltage is what? There is no neutral, but phase voltage is what? This is the phase part of it. One phase, this winding. So phase voltage is what? This V R B, V Y and R. This is Y and this is R, V Y R. And what is line voltage? Line voltage is also this one. So in this case, line equal to say, phase, same V phase equal to V line. That you need to remember. So this is these equations, these are the very basic foundation of your job career, particularly in design or wherever even if you are into maintenance in electrical engineering, or operations maintenance, or design, or inspection, or project, wherever you go, these are the very fundamental knowledge you need to know. So uh, in case of delta, the voltage, phase voltage is equal to line voltage. Now in case of delta, what is the current? Let's say the current is flowing like this, right? I, so it can be coming from here and going out from these two lines, and there will be different variations. So if it is like this, it can be current is coming here and then it is going like this. So this will be the scenario, right? Now what it means, that this current I, this I, let's say I, this is Iy. Iy is a vector sum of this phase current. This phase current, let's say I, vector sum of I C1 C2 plus I, this one A1 A2 plus I A1 A2, vector sum of these two. Now we will calculate what is the relationship between the I phase and I line in case of delta. But for the time being, you plus remember this. Now, what we have decided, that we will decide what is the three-phase circuit. I have just explained what is star, what is delta, and what is the relationship between phase current, line current. What is the relationship between phase voltage and line voltage. Right. One we have derived already, that in case of a star connection, this line current and phase current are same. In case of delta connection, the line voltage and phase voltage are same. Now in the next video, because otherwise this video is going to be very long, we will find out what is the relationship between this line current and phase current in case of delta, and what is the relationship between the phase voltage and